Ladies and gentlemen, on behalf of CSIR-NEERI, I Saveri welcome you all to this significant event, Dr. Ashok S. Juwarkar Memorial Lecture 2022. May I request Mr. Prakash Kumar sir to escort the dignitaries to the dais. Ladies. Thank you. Ecosystem restoration is the need of the earth. Since its inception, CSIR, National Environmental Engineering Research Institute, has tried hard to establish an ecologically healthy relationship between nature and industrialized environment. In this context, CSIR-NEERI scientists always endeavor to explore nature-based solutions for wastewater treatment and management at industries. Late Dr. Ashok S. Juwarkar, former head, Land Environment and Management Division NEERI, was the first scientist at CSIR-NEERI who initiated and developed land environment system for wastewater treatment. Late Dr. Ashok S. Juwarkar installed country's first high-rate transpiration system to treat pulp and paper mill effluent at Amli, Madhya Pradesh in 1994. He also installed the wetland system at Bhubaneswar to treat wastewater of Sainik School. Taking forward the work of late Dr. Ashok S. Juwarkar, Dr. Asha Juwarkar, former Chief Scientist and Head Ecosystem Division, CSIR-NEERI, has significantly contributed in the area of ecosystem restoration. When Dr. Ashok S. Juwarkar was on official tour to Shimla on 7 July 1996 for inspection of Hotel Beirut Heights, Himachal Pradesh, Dr. Juwarkar unfortunately died in the plane crash near Kullu while returning from Shimla. The institute organized Dr. Ashok S. Juwarkar Memorial Lecture every year as a tribute to late Dr. Ashok S. Juwarkar. To commemorate and pay homage to Dr. Ashok S. Juwarkar, we are assembled here. To mark the occasion, we have renewed personality with us Dr. Professor Sanjay Deshmukh sir as the chief guest. I request our director Atul Vaidya sir to welcome the chief guest with the sapling. Thank you all. May I request Dr. Atul Vaidya sir, Director CSIR-NEERI, to deliver the welcome address.
Dear all, on this day of July 14, we always organize Dr. Ashok Memorial Lecture to pay our tributes, pay our respect to his contributions to CSIR and environment. Today, I think most of the NEERI scientists present here may not be knowing him personally. Very few of us are actually there in NEERI who have interacted with Juwarkar. He was, I had a brief association with him because we were in the same division for a while, 1993. And then I think 1994 or 5, he was given a separate division. The first time this division was formed, Land Environment Management Division. And Dr. Ashok Juwarkar was made head of that division. Dr. Juwarkar has done pioneering work for the application of waste into agricultural fields, application of many environmental or application of agriculture for betterment of the environment and vice versa. Such is most country, if you remember or if you go to our on the exhibition, there used to be a triangular diagram, triangular matrix for soil. That was a really contribution, I think as a basic contribution from Dr. Ashok Juwarkar, he developed that diagram, which would tell you at a glance what is the type of soil and what it is suitable, the kind of nomograph. And then his pioneering work was there in the field of remediation of wastelands. Always we take our visitors to mine remediated spoilums near Tunga, near Nagpur. That is the work which was initiated by Dr. Ashok Juwarkar, and that is the greatest contribution he has done to the environment as well as the NEERI. And based on such technologies, that on many sites were remediated. In fact, today we are talking of bamboo plantation that was basically initiated by Dr. Ashok Juwarkar in his times. So use of plants, use of agriculture, use of application of waste into agricultural practices, irrigation, and all these contributions are basically from Dr. Ashok Juwarkar. And we still remember the day when unfortunately he was on tour to Himachal Pradesh. And on 11th of July, his flight met with a very bad crash in bad weather in Himachal Pradesh. And unfortunately, Dr. Ashok Juwarkar succumbed to the death. And his cremation was because there were many procedures involved, and his remains were brought to Nagpur. And he was cremated officially on the date of 30 July. That's why we organized this lecture, pay our respect to Dr. Juwarkar on this day. This I am narrating because there are many, rather there is a majority of the NEERI scientists or NEERI staff who don't know the contributions of Dr. Juwarkar and probably wondering why we commemorate this day. Those I am giving this information because I had a chance to work with him. Today we have a very prolific speaker, Sanjay Deshmukh, who is expert in his own field, to life sciences, and he will be formally introduced later on. But I am very happy that he has agreed to come here from Mumbai and deliver this lecture. So you are the Memorial Lecture. So on behalf of NEERI, I welcome you all and I welcome Dr. Sanjay Deshmukh for this occasion. Thank you very much.
Thank you, sir. I move to the main segment of the program, Dr. Ashok S. Juwarkar Memorial Lecture 2022, which will be delivered by the chief guest, Professor Sanjay Deshmukh. But before that, I would like to introduce the chief guest. Dr. Sanjay Deshmukh is currently Professor of Life Science at University of Mumbai and also Adjunct Professor at Institute of Chemical Technology, Mumbai. He is one of the India's widely acknowledged life scientists and also academic thought leader in higher education. He has served as youngest ever 55th Vice Chancellor of University of Mumbai. He has received two DSc degrees from Ram Manohar Lohia, Awadh University, Uttar Pradesh, and University of Science and Technology, Meghalaya, respectively. In recognition of his long and dedicated service to the cause of application of science and technology for securing sustainable livelihood in general and for bringing academic and administrative reform in the University of Mumbai in particular. Professor Deshmukh has a vast R&D experience at national and international level spanning over 50 countries. Along with Professor M.S. Swaminathan, he originated the Global Cost and Marine Hotspot Strategy for Conservation Planning, which generated over 500 million US dollar for global conservation activities, the largest sum ever assigned to a single strategy. His work on mangrove ecosystems led to the establishment of a global network of mangrove genetic resources conservation centers. He also developed people-centered hotspot strategy for conservation planning through extensive first-hand study on sacred blue in Maharashtra state. He has rendered a strong strategic leadership in global environment and development issues. Professor Deshmukh as a scientific consultant and policy advisor to several countries, as well as intergovernment agency and Government of India at state as well as central government level. He has received many prestigious honors and awards. The notable ones are Best Village Development Award through bamboo reforestation conferred by Ministry of Environment and Forest Government of Maharashtra in November 2010 and Best Village Industry Development Project Award in 2009 by Ministry of Micro, Small and Medium Scale Industries, Government of India. He is a fellow of several scientific bodies, academies such as Mangrove Society of India, National Environmental Science Academy, International Society for Science and Technology, Lead India, Fellow of Society of Bioscience, etc. With this, may I request Chief Guest Professor Sanjay Deshmukh sir to deliver Ashok S. Juwarkar Memorial Lecture 2022. Please go.
Namaskar and good morning, everybody. At the outset, while paying my respect to late Shri Ashok S. Juwarkar, I also would like to fondly remember his wife, who had also been an eminent scientist. And I had the privilege of reading some of her research papers recently. And it was a coincidence that I got a phone call from NEERI to be invited for this very important event being organized by NEERI every year. And therefore, I deem it to be a very privileged person to be amongst you this morning to share some of the experiences that I have had with my colleagues, my teachers, my students, and my collaborators in the last 32 years of my active research. Today, we have amongst us Honorable Director of CSIR-NEERI, Dr. Atul Vaidya. We have Dr. Kumhare, Senior Principal Scientist, who was instrumental on the request of the Director NEERI in inviting me to come here. One of our senior scientists in the field of agriculture, Dr. Purushottam Shukla sir, who has been a doyen of agricultural research representing Vidarbha. He is also amongst us today. One of my more than 3-decade-old friend, Dr. Vivek Damle, who is here, who also represents the University of Illinois as ambassador of the university to India. We have one of the very eminent scholars and technologists, Dr. Viniwale, who is here amongst us. We also have many research scientists, particularly from this great institution, CSIR-NEERI. One of my friends from Nagpur, Satish Kakar, also is likely to be here to attend this oration. Research scholars from various departments of NEERI, eminent scientists from other institutions, and teachers and professors, and non-research colleagues of NEERI. I tend to call non-teaching colleagues because I represent University of Mumbai. So most of the times we refer to non-teaching colleagues. And of course, the members of press and print and electronic media. This particular oration has been one of the landmark events of NEERI. And I was glancing through the previous speakers who have honored the request of NEERI and delivered this oration. They are very tall personalities. And in that comparison, I feel I'm just a beginner in the field of research and development, though the number of years I have spent is more than 3 decades. There are instances where you start your career as a researcher, you have dreams to be able to continue that even after your formal education. Many times it does not happen. But whatever is important is the education that gives you wisdom and a capability to stand on your own feet, besides strengthening your mind. And that is what was the message or definition of education offered by Swami Vivekananda. And with that, when I see large number of researchers who are aspirants of doing something in life, and they have joined this outstanding institution of eminence, I would just like to advise them that the knowledge which they will gain while doing their formal education over here is going to be applicable in every field if you look at it from that perspective. And the expertise that late Dr. Juwarkar developed and possessed and implemented with respect to restoration, that is the motto of life, I personally feel, because anything that can be damaged by anthropogenic pressures or human interference, it can be restored. And that is what is important if you look at your own life. There can be some instances where you deviate from your objective, but at the same time, you have to keep one thing in mind. If your perseverance and commitment is there, you can come out from every difficult situation. And that is what the environment is all about. There has been an exploitation at different levels by human interventions. Most of the times it is said that they are useful for human development, which is rightly so. But we forget one thing, that while proposing any development, we do not plan conservation measures. And what is conservation? It is preservation and utilization. So we should not just keep on conserving something for the sake of doing it. And therefore, if there is some amount of disturbance in the natural state of environment, it is very important for us to look at those areas where scientific interventions can play a very important role for overcoming these problems. And we can restore most of the damaged environment with the help of technology. The National Education Policy 2020 envisages providing opportunity to individually every student who is aspirant of doing something in life. And we have more than 18 crores of students below the age of 18 years. And there is a great hope that our nation will take a lead in the area of education and through that, in every sector of environment and development. With this, I would like to start my presentation. It encompasses largely the areas of restoration ecology. I was trained as an ecologist and then was very fortunate to have had an opportunity to work with the father of this revolution, Dr. M.S. Swaminathan, who still at the age of 97 is more active than most of us who are in this August gathering. And the inspiration that he has provided can be uncanny. The vista that are opened with everybody who works with him are enormous and beyond our imagination. And therefore, the presentation that I'm going to share with you is largely going to be around restoration work, which I was directly involved in, initially as a research student with my professor, Dr. Sharat Sapekar, who at the helm of his academic career pioneered some of the restoration ecology work in India. In addition to that, phytomonitoring of air pollution. And the technologies developed in contemporary world in early 80s. I'm sure Dr. Juwarkar was very active in his own way with respect to development of technologies. Dr. Sapekar looked at using plants as indicators for environmental stress, and not only that, learning lessons from that, and using some of these plants or indicators for restoring degraded habitats. He looked at the Zawar mines, the oldest mines in the world of zinc and lead, more than 4,500-year-old mines in Udaipur. Zawar mines, they are called, run by Hindustan Zinc those days. And restoration of those mines, particularly the mine waste, what we call it as tailings, and all of you are aware about the word, because you are all from NEERI. The introduction of plant cover for restoration of mine waste was one of the projects that he initiated, which was a pioneering work those days. And my senior Dr. Bhavani Shankar worked for his PhD. When I just passed out from my master's degree, actually I had just completed my exam. My sir asked me to join Bhavani Shankar and help him in that particular project. And eventually then I switched over to a research project that was dealing with mangrove ecosystems to restore and monitor the biodiversity of one of the largest ever tracts of mangroves in Mumbai, more than 3,000 acres of lush green mangroves. You can imagine the cost of land in Mumbai is almost 500 crores per acre. 3,000 acres of mangroves for protection. I moved to Chennai. We looked at eastern coast of India. Restoration techniques that I had learned and imbibed, they had changed. I used to travel a lot. I still travel And that exposure also gave me a chance to interact with global scientists to look at restoration practices, particularly the coastal ecosystems. And we looked at what we call it as joint forest management, the JFM principles of the forest department. We looked at joint mangrove management, the first ever concept that we implemented in the country and anywhere in the world. The people-centered development by involving them in the government lands, providing them livelihoods, casual labor costs every day, and asking them to maintain the forest areas and utilize them, extract the resources which will not be harmful to the forest ecosystem. That was the concept where the restoration of more than 50,000 acres was done. Eventually, which we started in 1992 in Peshawar mangroves. There is a third example I would like to give. Second example is the Victoria mangrove where I initiated restoration as a part of my PhD. And coming down to biodiversity of inland areas or Western Ghats, the sacred groves, the biodiversity hotspots, people-centered biodiversity hotspots, which are managed by people imbibe within themselves the idea that there is an element of God. It need not be Hindu God, any God. I've seen sacred groves which are named after Muslim people of respect or religious leaders, and they are still preserved in that belief. So, sacred grove also was a very unique concept, and restoration of that by way of collecting the endangered species from the forest, from the sacred groves, developing the nurseries and the degraded forest areas of Western Ghats, where we can revive some of the areas by initiating plantations and create a sacred grove. Eventually, it will become a kind of biodiversity hotspot. So these are four examples that I want to give as a part of my homage to Dr. late Ashok S. Juwarkar sir and his family. I'm sure wherever he is watching his disciple, his collaborator, and his alma mater, who has given so much recognition to his work, to himself, and the legacy he carries forward to all of you. This particular presentation, as I said, is going to be the outcome of actual research done by me and my colleagues, my seniors, under their guidance. And therefore, I will not present the data in terms of tables, but the results in terms of photographs, which will be more appropriate for the time that we are going to spend on this presentation, now about 30 minutes. I must have spent 10 minutes by now. And it will give you a glimpse of how much efforts go in. Just one photograph is a matter of a span of 20 years. You see one slide, one photograph 1986, you see another photograph of 2004. And what has transpired between the two is enormous amount of papers and research. This particular slide, I just want to dedicate to Dr. Ashok Juwarkar, about whom a very lucid introduction and the contribution that he made to the field of science and technology was mentioned by Honorable Director, and I have taken parts of some of the letter that he wrote to me. And this part I will put in some points, highlighting the work of Dr. Juwarkar and pay my respects to him. The slide that I am trying to show you is a map of the world, a two-dimensional figure. What I'm trying to highlight here is that three-dimensionally we are not in a position to understand where we stand as a human being, as one species. We are one among 17.20 lakhs species, individual species on this planet. And all these species are actually identified by us, human beings. There can be 100 times more number to what we have discovered so far. And rightly so, because there are so many areas which are unexplored. The oceans themselves are a repository of the largest number of phyla on the planet, and a lot of that is unexplored. But just to give a brief idea to you, if you draw an imaginary line of 60 kilometers from the coastal areas of the world, 63.5% of the world's population is residing in just 60-kilometer belt of the coastal regions of the world. It is also a home for agricultural lands, the agriculture, because the people who settled, they were hunters and gatherers. And eventually they realized that they can domesticate some of the wild varieties of plants, we call them crops now. And they can grow them, stay in a location for a longer period, and harvest the products or produce of the agricultural crops, and then they can keep on going. And that is how the population also kept on increasing. The very map shows you the tropical belt of the world, 25 degrees north and 25 degrees south latitudes, roughly. That is also a home of 77% of world's poor, but it is also home of 77% of the world's biological diversity. So the biologically diverse areas are ecologically diverse, but economically poor, because they are home of developing nations. And that is where the problem starts, because the population pressure, as I said, within 60-kilometer belt, the pressure on the biological resources, and the hotspots of biodiversity, which are shown in the red color on this particular map. And they have as many as more than 40% of the endemic species of different divisions and classes, and like vascular plants, birds, endemic mammals, and so on. You must have read this already. And at the same time, if you look at India with more than 45,000 plant species diversity and many more in terms of animal and bird and microorganisms, it occupies just 2.4% of the world's land area and accounts for nearly 7% of the globally recorded species, while supporting 18% of the global human population. So with this particular pressure, how do we really plan? We are just 75-year-old nation as far as our independence is concerned. And the legacy that we have carried forward in terms of education, the cultural shocks that we have had to the invaders of the nation, and the situation we are trying to overcome to maintain our GDP, the gross development product. How do we really manage that and make each and every individual of our nation happy? 500 years before today, the global contribution or India's contribution to global GDP, as you can see on the left hand side of the bar chart, was about 23% contribution of India. But that drastically came down to just about 2.3% in the year 2000, when the United States had overtaken everybody and it reached a level of 22% of the contribution to global GDP. And that is a kind of decline in terms of GDP. But now we are just catching up and talking about 8.7, 8.9, and so on. But at the same time, we should also realize that GDP is not the only measure of making every individual or making the benefits of our development to the last segment of our society. And therefore, the gross national happiness is another index with which the nations are judged. But if you look at this particular map, the United States of America was not on the map of the world at all 500 years ago. So within less than 400 years, this nation has made enormous development, and we need to learn something from each of these developed nations. The Zawar mines, 40 kilometers before Udaipur, traveling was like by normal train to Ahmedabad and by narrow gauge train to Udaipur. Before 40 kilometers of that, we used to get down at Zawar, and that was the largest and oldest mine of zinc and lead. Those days in early 80s, the production was like extraction was about 4,700 tons per day of zinc and lead ore, and hardly less than 3% would be the extracted zinc and lead. So remaining 97.5% or so was done by identifying the strategic location of Aravalli Hills. From three sides the hills were there, and from one side one could keep on building the wall and dump that mine tailing through the pipes mixed with water, so that the liquefied form of this mine tailings, they were not soluble, of course, but they used to be dumped, and as the level grew, the wall on the other side was built eventually. It raised the ground level up to about 30 meters. And at one point of time, 75 hectares of land was covered by the field mine tailings. With just about 15 kilometers per hour wind speed, the tailings would go from that location to nearby areas, including rivers and roads and so on, and contaminate the entire microclimate, including water bodies and eventually the fish and other fauna from the water and agricultural lands. To overcome this problem, a research project was granted to the Institute of Science, Mumbai, where Professor Sharad Satekar was coordinator and one of the leading ecologists of our nation. And he started this work, took it up as a challenge, and Dr. Bhavani Shankar worked on it and assisted it for 2 years. I did not have a report of that because I was a research assistant and I didn't get a copy because that is not the practice. And I had to cull out some of these old photographs, so they are not as clear as one would like to see them, but they are all 36-year-old photographs. You can imagine the clarity may not be that much. And a few photos I have also downloaded from the website of Hindustan Zinc Limited. Those days, their annual reports. But what I'm trying to say is the gully formation that used to take place in the photos that you see on the top left, that was the kind of looseness of the mine tailings. And one would have to really struggle even to walk on that when the settled mine tailings are not there. There also be still water when they're actually dumped. So on this particular surface, what could be the solution? What kind of plants would grow there? And we looked at the surrounding areas, surveyed the surrounding areas to see the plants and other forms of vegetation, which are also growing naturally on the tailings which are flown by wind to the nearby areas. And what was the local vegetation that was withstanding or able to withstand the stress, environmental stress and the industrial stress, and manage there. And we looked at various normal species, herbs and shrubs and even grasses. And a very typical and common grass called Cynodon dactylon, as all of us know, was found to be growing much in a much better way in any of the contaminated areas, basically the mine tailings blown by winds. And then trying out what could be the mechanism to hold this particular substratum, which was just in powdery form. How do we really look at holding that by introduction of plant cover? So whether we could mix some cow dung, cow manure, or some chemical fertilizers and look at the enhancement of richness of the substratum, and then introduce even the surface that was plain, whether there could be some slopes created artificially, and then you can grow Cynodon dactylon, which we found to be more suitable. And as the ecological principles go, the succession process, where the first species that is introduced is grass, and then eventually the higher plants keep on getting introduced. So with that philosophy, with enormous amount of research that was carried out by Dr. Bhavani Shankar under the guidance of Dr. Satekar, we came out with a solution of introduction of Cynodon dactylon with various combinations. Like as you can see the diagram, the hand sketch, you can see what kind of slope you can have. 15-degree slope was eventually found suitable. And then we looked at various combinations of density of grass that could be planted, and then the amount of chemical fertilizer that could be added, and also the cow dung that could be added. And based on that, we realized that a very effective plant cover can be introduced by having a slope of 15 degrees and 100 kilograms per hectare of NP addition of that. And with that kind of substratum, the Cynodon dactylon can really show fantastic results. So eventually, based on that, we were able to create a green cover. And this particular green cover was established after an experiment which we conducted and implemented on 2 hectares of land. And we were able to show that, okay, this can be grown successfully. And of course, 30 years down the line, now it has become a very dense vegetation of herbs and shrubs which got introduced automatically, of course, to the cow dung and other manures that were added eventually every year. So this was one of the success stories of introduction of plant cover on zinc mine tailings for restoring the mine areas. Of course, this was one of the underground mines, and therefore the impact was totally different because the mine waste was done in the external or identified location away from the mining area. But similar work also was done by Dr. Sapekar in the open pit mines in locations near Regula. And a different strategy of ecological restoration was adopted. I will not get into that because I already have decided to give 4 examples. The second one is Mumbai, the Iron City, the mega city, the only city in the world which supports a population equivalent to Australia. Now we are already in Australia. And in an area of 604 square kilometers, out of which 104 square kilometers is Sanjay Gandhi National Park. With 500 square kilometers, if you have 2.5 crore population, then 55,000 persons approximately per square kilometer is the density. And in Dharavi, it is almost 80,000 people per square kilometer. And we are staying happily. We welcome everybody. And we still have a good mangrove area surrounding the city of Mumbai. As I said, 1/6 of the city's geographical area is a national park. Nowhere in the world, a mega city like Mumbai, which has got 1/6 of its land protected legally and maintained, is seen. And similarly, on the eastern side of Mumbai Island, you have 3,000 acres of land and the mangroves under the ownership of Sunamai Pirucha Godrej Foundation, which sponsored the project again to Dr. Sapekar, where I was appointed. None of my colleagues wanted to go into the marshy areas. One of my very good friends and very talented friends was offered this particular fellowship by my sir, but he said, no, sir, I have some file problem, which he did not have. But he didn't want to get into the swampy area and get into, the salt water and so on. I took it up as a challenge. It was a great fortune that I got this opportunity. And this particular area not only opened various vista in my own career because I traveled on motorcycle more than 125,000 kilometers just to study mangroves from Gujarat to West Bengal. And I didn't have a motorcycle. I traveled on my bicycle from Thane to Vikhroli for 4 days. I had a canoe, a dugout canoe to do rowing in that entire area and visit these locations. And those days, the satellite imageries from Mumbai were not accessible because of the security reasons. And we had to apply the ecological techniques for mapping these areas of mangroves to look at the forest cover, to look at the density, to look at the quadrat study based population density of mangroves, the height of the vegetation canopy, and strategically 4-5 different categories based on that. And the basically barren areas within that forest. And that particular map, I took almost 2.5 years to prepare. So this is that map where the vegetation in the form of light green color, and you have this orangish color that is a barren area. And on the right hand side, you have the various categories of the vegetation that we were able to do by actually plotting 400 quadrats of 10 by 10 meters square and more than 100 transects from different locations from the coast to the inward region up to the barren areas. And that is how the categorization of the mangrove forest was done practically manually. 10 years down the line, we had access to the satellite imagery, and you can look at the right hand side photo. And that we were able to match with the satellite imageries, and we could get the result of almost similar, just about 5 to 7% difference in the satellite image based map of the same region and the manually prepared map. The restoration techniques, I was the first to buy large scale saplings of mangroves from Forest Department as earlier in 1986. Forest Department did not have a concept of growing mangroves through nurseries and selling them, like how they sell other plants to local people or farmers. And that was the time when we had to look at the barren areas and how these barren areas could be accessed to the tidal water, whether we can cut across by artificial canals or dug out some of the existing canals to reach the tidal water frequently so that the natural habitat can be created or recreated. And then you can go for plantation of certain species which would grow based on the salinity tolerance levels of each of them in this particular area. And this is how the experiments the work that was carried out, and we were in a position to come out with the results 25 years down the line, 36 years down the line. The orangish patches that you could see in the first map, they are now largely covered with mangroves which we planted, and the facilitation of water in the barren areas also gave rise to flowing of the seedlings of mangroves to those areas, and they settle down and they have also grown. So this particular barren area you can see in the central photograph, you can see now the same area on right hand side of that. The barren area is also getting filled up. So restoration by way of developing nurseries, transplanting the nursery, grown seedling, and also directly transplanting seedlings of mangroves, which were brought from different areas and planted there and stored there. Gave an idea to Dr. Swaminathan, who visited that area on 14th of January 1988. That was a Sankranti day. That is how a person like him came in my life on Sankranti day. And he said, you are doing genetic resources conservation. What a fantastic work you are doing. I didn't even know that the nurses that I was talking to the genetic resource center, because I had collected seedlings of different species of mangroves from different parts of the country, largely from Maharashtra, of course. And he said, I would like to keep coastal system research as the first thematic area of my foundation. We were just about to register his research foundation after completion of his PhD form A. And that is how I got an opportunity to work with him. So this particular initial work I was able to expand in Chennai. You can see this satellite image on the left hand side, the satellite image of 1986, where you can see the grayish patches, which are barren patches which I had prepared manually in the form of map. And on the right hand side, the same area you can see almost 95% is covered by mangroves. So that is how the natural restoration also takes place if you protect the area. And also in the barren areas, you can have ecological interventions, engineering interventions. One of the students of Sir is a civil engineer who received me in the morning. He was talking about his knowledge and application of knowledge for me. So, Master Sontag. So, Kumar sir has got diversity of students. Saveri also was excellent in her oration. And of course, I'm sure she's good in her research as well. So, these are some of the outcomes of the research that you do for years. It is not just overnight research that you do. The experiences of Vikroli we were able to implement also later on with the help of MMRDA to monitor and provide protection and some intervention to mallard mangroves. And here you can see the progressive maps that you can see here, 1991 on the left hand side, where the yellow patches are mangroves. 1997, green patches, they have come up freshly by this protection and creating certain artificial canals where the tidal water can reach. And the green patches are added there. And that is how the yellow ochre color on the right hand side top is the growth of mangroves, percentage growth in just 7 years. So when we did this project for MMRDA, the total MMR's mangrove had increased by 2.5 times. And I was, well, you are a fool, you cannot have that much growth because Mumbai's mangroves are exploited. But I could show you with the help of satellite image. And I was at that time working with BNHS, so the conservation organization, the principal scientists talking about the growth 2.5 times. They were not in a position to believe. But when you have a mindset of development, which is also conservation and utilization, then these results can be achieved and policymakers then can take measures. The Pishavaram mangroves, over 1,300 acres of land under mangroves, sporadic mangroves, because when I started working there in 1990 December, it was like a very difficult area. The first time in the country, probably in the world, 100 hectares of land from this area was offered to Swaminathan Foundation, where I started my career. And the principal chief conservator of forest, Mr. John Joseph, was the first forest officer who provided 100 acres by signing an MOU that we are giving you this land for 30 years for research. But by that time, we had developed this concept of genetic resources conservation centers. The first we wanted to establish in Peshawar. And that is where we started working there. We implemented the concept. There were a lot of hooping was done due to which for the previous 40 years before 1990, a lot of areas had become barren. The substratum had raised, the water would not reach, or if reached, it will be remaining stagnant there. Higher amount of salinity will be there, and that is how nothing will grow there. And you can see the stumps, which were the clear-filled hoops of mangrove or forest department themselves, and they could not be living in that for various reasons. So we studied a very systematic ecological experiment, and we were able to understand that there was some kind of a trough-like situation where on both the sides the mangroves are there, but the water would come there at the time of high tide or highest high tide. And it will remain there. That's how the salinity levels will go. 150 parts per thousand, 200 parts per thousand, and nothing will go there. So we were able to have engineering technology, the civil engineering technology of road construction that we are aware of. We looked at the gradient of the land. We looked at what kind of gradient we should have for the canal that we are going to dig. The fishbone canal, you can see some of the fish, you have a main vertical column, and you have a typical alignment of other bones. So with that kind of design, we were able to implement those canals in some of these areas. Vertical canals also, parallel canals also. And looking at the depth of the water, how much water can be brought in into those barren areas. We were able to involve the local people who were actually doing fishing and extracting some of the associated flora and fauna without disturbing mangroves. We convinced the forest department, and that is how the first joint mangrove management program was born. And with the help of that, we provided them livelihoods. The local people would work there, they would work with us. We were able to march and harp on the traditional knowledge of the people in terms of their geography, their topography, the features, the ecological features of the village, the danger areas, and how we could develop what we call it as anticipatory research with the help of local people. And we were able to map the mangrove without even going for satellite imageries. And local people would draw on the ground with the same precision as scale. And we would be able to then gather the women, we were able to establish self-help groups. And in these communities, we were able to conduct an experiment and convince them with the help of Forest Department and my colleagues from the MS Swaminathan Research Foundation. What are the benefits that they can accrue by working in the forest where they will get the livelihoods, they will get the daily wages, and they will be able to utilize the forest despite working there and despite the ownership that belongs to the forest department. And that is how these barren areas we were able to identify for pilot scale joint mangrove management program. We had a flow chart like situation analysis, selection of project hamlets, participatory rural appraisal, formation of village level mangrove councils, identification of mangrove management unit, preparation of annual micro plan, and implementation, monitoring, and evaluation. These are some of the villages that we identified and the areas in hectares from different hamlets under which category of forest they were in and how we could go for large scale afforestation by ecological engineering technique. And these are those some of the canals that we had dug in. And you can see on the top right, a single straight canal with a particular depth with a kind of angular banks of the canal, and the water will be felicitated. This particular photograph is like a fishbone canal design, and the same fishbone canal here, after plantation by people, it got converted into that within 3 to 4 years time. And eventually, you can see the next slide, you can see the people working and the mangrove formation after 5 to 7 years. So this is how the technology where the areas that were conducive of mangrove plantation, but they were devoid of mangroves, barren areas. In the entire east coast of India, we convinced the state departments, forest departments, and implemented this JMN program. And believe me, in 1992, we had planted in Karaikal and Tuticorin and Nagapattinam region, 2 to 3 kilometers away from the coast, a straight bioshield of mangroves, 1 kilometer wide and 4 to 5 kilometers in length. And that grew up to 10 to 12 meters by 2006. And when tsunami hit, the entire villages, they were behind that mangrove cover. They were protected just by this bioshield of mangroves. 5 to 700 kilometer speed per hour of waves. They were rushing towards the coast and this mangrove plantation. So this was the vision of Dr. Swaminathan, where he talked about anticipatory research. When we saw the mangroves in 1988 from a watchtower in Vikroli along with me at 6 o'clock in the morning, he said, Sanjay, these are the only plants which have the ability to withstand not only salinity, but also withstand the submergence of salt water. And we have to identify tolerant genes, tolerant to the salt stress, and if you can transfer them theoretically in the landward plants like crops, you can make those crops survive in saline water. When the sea level rise may take place and coastal areas where we have highly rich lands of agriculture, they will be inundated by tidal water. What will you do? These are the solutions that we are there to find. And believe me, 11 years after that, my colleague Dr. Ajay Parida came out with a breakthrough. He started with me. I had come back after 5 years to Mumbai and he continued the work. We got Padma Shri for a genuinely outstanding work. We identified the salinity tolerant genes and transferred them into rice. We grew rice in Kalpakam in the DA location. In the salt water, in the sea water, by giving sea water and having the same amount of production. So these kind of restoration works coupled with what we call it as molecular genetics technologies. They have been actually the real solution. We have to go by traditional knowledge and also couple that with the modern technologies. That is how we were able to come up with lots of solutions. And you can see very distinctly 1986 satellite image and 2002 satellite image. The mangrove cover which can be seen in the red color, it has grown about 40-45%. That's what it was in. And we have given livelihoods to the people. It's not just the protection. So this is the symbiotic relationship we have to develop. The last segment of my presentation, I will take not more than 5 to 7 minutes. I'm sorry, I exceeded a little bit. But this particular aspect of sacred groves, the entire universe had wisdom. People were aware about the importance of sacred groves. They had assigned them titles that this is the land where the God is there, element of God is there. Don't touch anything, don't extract anything. And those are the patches which are remaining today in the form of sacred groves. We had a World Bank project which I coordinated as a principal investigator in 1996. And in less than 4 years' time in Maharashtra alone, Maharashtra's geographical area is I think 307,000 square kilometers. And the sacred groves that we identified, which are about 3,800 in all over Maharashtra, largely in the Western Ghat region, ecological agroclimatic region 1 and 2. But 3,800 sacred groves, they were actually in only 6,000 hectares of land. But more than 1,300 different plant species were recorded in these sacred groves, where Maharashtra's number is 3,500, more than one third. And we were able to not only identify those plants, look at the medicinal plants value, the ethnobotanical aspect came in. Many sacred groves were degraded, and I had in mind how to go about it, how to provide solutions to the people that they can contribute, like how they had contributed in JMM in Tamil Nadu, where they can be involved in restoring these sacred groves. The experiment was started 2-3 years ago in Sindhudurg district. One of my very bright students, PhD student, an MSc in agriculture, and he has decided to live his life with the farmers, for the farmers, without doing any formal job. He has got about 6 acres of land, 6 acres of land in Pudar, Piguri, they call it. It's a land of Sant Rahul Maharaj. Again, Konkan is very blessed, like Vidarbha region, with great sense. And in that area, we have been working with more than 300 farmers to look at the stresses that they have by way of human pressures, by way of animal pressures, by way of policies, and also by way of calamities. And he has been able to look at the rare and endangered plant species in the red data book that are listed from the Western Ghats. Developed nurseries, one of the major contribution of his is also bamboo nursery, as Dr. Director Sir was mentioning. And these nurseries are repositories of genetic resources. These are some of the biodiversity hotspots I just want to give you a glimpse of. And models of ex situ conservation, where local edible wild mushrooms or black pepper on native trees are some of the examples. The bamboo nursery in Piguri, which my student Milind Patil has developed, and various different species of important fruit trees like Rhizoxylum binectariform, collected from multiplication from a privately owned forest. So we have been able to do experiments. This is again another home garden, which is a repository of very many plants, and we have been able to develop nurseries. We have nurseries of Mamia Suriga. One village we have got hardly 11 trees of Surangi, what we call it. But the economy of those 7 villages is based on that. Every year in the flowering time of Solangi, they earn about 2.5 crores. And that is the income of the entire village. You can imagine a lot of things based on the traditional knowledge and coupling the economic efficiency of farmers and the potential of markets. I think we can provide those livelihoods. We have been able to have an experiment on the 5th June this year, and we identified a degraded area where the seedling that we had gathered and grown in the nursery, we planted them as if it is a sacred grove that we are creating. And I'm sure many such sacred groves will be created eventually with the help of local farmers. And they will be an example of restoration of the rich heritage of our country, the Western Ghats of India. And this is one experiment. My student village is in half pant here, white shirt, half shirt. Cannot even think that he is a PhD student because he's like a farmer. He's dressed like a farmer because he's farming actually. So we have been able to motivate his colleagues, many friends from NSC Agri, NSC Forestry, background from Napoli, and they have been doing fantastic work. They have been a very strong force to provide the policy guidelines even to the people, to the ministers. So this is how we are able to create future in situ conservation areas. So restoration is not just a degraded area because of human interventions. It can be a natural degradation. It can be a barren area which can be conducive of planting something. You have to identify, you have to have a wisdom based on the people's knowledge. And we should be in a position to come out with a great solution. This is the area where we have been able to identify these pockets of degraded areas, and we are trying to create sacred growth by a diversity of species which are collected from the very region. And therefore, what we call it hope through ecology to restore the degraded areas onto biodiversity hotspots in the future. Godrej, the foundation, the Sunamai Pirojsha Godrej Foundation, 3,000 acres of land maintained for more than 122 years under their ownership. They just want to protect it, no construction. You can imagine the cost of that land. That foundation gave me my PhD fellowship. Initially it was 1800, then went on to 1800. I used to make a presentation to the trustees, to the likes of Salim Ali sir, Dr. Setna from DAE, Dr. Shri Awati, Manohar Awati, the Vice Admiral, or even SP Godrej. And those people were the trustees, and I used to make a presentation every second month along with Dr. Sapekar, because that was a project. And 30 years down the line, I got a call from the Godrej family. Sanjay, we want to request you whether you have some time for us. I said, always, because you have been people who have brought me to the level that I am. They said, why don't you honor us by becoming a trustee of this foundation? Can you imagine? I could not control my emotions. I could not believe that the foundation which was graced by such great people, they have invited me to be the trustee of that foundation. I think this is the reward that you can expect. Your DSCs and any reward is secondary when you have such recognition. So I feel that I should show this slide which Godrej company promotes as their motto, and they are saying, when your heart is set on caring for the lungs of the city, you are not just making in India, you are making India. And that is the motto of our Honorable Prime Minister. So we're talking about making India. So the exploration work that was started by Juwarkar sir as earlier in early 70s, I'm sure 75, I think he joined NEERI. One of my very dear friends and my mentor, and there are many friends like Vivek and many others who have been my idols. So I've learned from every one of them. Dr. Vijay Kulkarni, who was in NEERI, and he had to go to Mumbai because he wanted to treat his children for their medical purposes, and he left his job and went there. He used to remember Juwarkar sir and many others like Vinivale sir and of course Director sir. And I have very fond memories of this place. Like Dr. Vate, I had come for the first time when Dr. Khanna was there, P. Khanna. And what a person. In the sense, they were like examples. And he used to feel Dr. Swaminathan is his idol, that kind of a thing. So what I'm trying to say is that we have to learn from these experiences. This institution has a legacy. If you just go to the library, you find wealth of information created by every director. That is the real knowledge that you should be looking at besides your own PhD work. And last two slides I want to show before I end. The hope of the world that people used to call Mahatma Gandhi. And he used to say that forget the past, remember every day, dance for us from the moment we wake up. Let us all, everyone, wake up now. When in 2001, the Time magazine came out with a list of 100 most influential people on the planet in 20th century, there were only 20 Asians in that. And out of those 20 Asians, we had only 3 Indians. And who were they? Rabindranath Tagore, Mahatma Gandhi, and one of the greatest scientists, the greatest human scientist in the world, who is surviving today, Dr. N.S. Swaminathan. You can imagine at the age of 97, he's still going to office at least about a couple of hours. In entire COVID time, he was in the office at 9:15. The director would come at 9:45 because the 10 o'clock was a punching time. So you can imagine the commitment at this age people have given. And everybody from agriculture, everybody from any field wants to just meet him once and you get a chance to work for 5 years. You can imagine what kind of impact this person can have. No Nobel laureate, you will correct me if I am wrong. No Nobel laureate in the world has got 91 honorary doctorates, out of which 70 are from abroad. And last 20 years I have seen at least 500 universities have approached him. Sir, हमारा DSc ले लो because जो उनका नाम बढ़ेगा. You can imagine. But this is the kind of people, these are the kind of people who are inspired. And what he said, what we are doing is just a drop in the ocean. But the ocean would be less because of this missing drop. So you have to keep on trying. One Juwarkar has given rise to hundreds of Juwarkars from this institute. And that is how the legacy carries on. A memorial lecture of after his name, or he would dedicate it to his name, is a great honor. And I feel very honored that I am standing before you, just trying to share a drop in the ocean that I have tried to contribute. But that is also important. Therefore, there could not have been a better tribute than talking about restoration, which was the initiation of the technology from NEERI for the country and from the world by Dr. Juwarkar sir. And I am really honored that I am here. Thanks to Director sir, thanks to Murray sir, and all of you for giving me a chance to come and share my experiences with you. I'm grateful to the Almighty for this opportunity. Thank you very much.
Thank you, sir, for your enlightening talk. May I request the director, CSIR-NEERI, to honor the chief guest by presenting moment. Thank you all. I request Mr. Prakash Kumar sir to propose vote of thanks.
Honorable dignitaries, my colleagues, invitees, students, teachers, media persons, all my friends from NEERI. Today's lecture was really enlightening because what I see in that is whatever case studies have been presented. So if I see in terms of mangrove restoration, in what is presented or chief guest has presented in Tamil Nadu and Maharashtra. In particular in Rajasthan, what he has told about this restoration of these Jawar mine tailings, and then some community participation. What was really inspiring for me, what I observed from this was the traditional knowledge, combination of traditional knowledge with science and technology. So I think this is the need of the hour, and this is the NEERI also, I think, should work on this area. Is how can we exploit, how can we use our traditional knowledge with science and technology for betterment of the environment, for restoration purposes. And what we have said that without community, because community, we have old people, we have medium-aged people, we have small people. So knowledge is not like that. If I say in Hindi, electricity, इस नॉलेज हम कहीं कि हमने PhD कर लिया, DSc कर लिया, कुछ भी, लेकिन एक फार्मर भी अगर 90 इयर्स ओल्ड है, 80 इयर्स ओल्ड है, उसके पास जो ट्रेडिशनल नॉलेज है, तो हमारा कर्तव्य है जो उन्होंने बताया दैट इट इज अवर ड्यूटी, because we have learned people, we have gained knowledge in science and technology. So how can we integrate this knowledge, traditional knowledge, with our science and technology? I think that would be more useful for the country, for betterment of the nation, in terms of environment, in terms of agriculture, in any field. Means, we have pharmacy students also here. So from environment field also, or agriculture, science, or anything, means we are integrating this traditional knowledge. It will be very useful for us. So thank you for giving us this message. And in spite of the busy schedule, because when I contacted you with Mr. Really accepted an invitation, thanks for that. And on behalf of our staff and director CSIR-NEERI, I really thankful with sincerely thank you for kindly accepting our invitation and came, because I think some difficulty you have faced because your flight was rescheduled, and then early morning because you have to wake up at early at 3 a.m. Today. Our director sir has been always his unstinted support, his guidance. So he has also told that what agricultural science is there for betterment of environment. He has pointed out that what Dr. Juwarkar has laid this foundation, and that foundation still is relevant. This is what we have to learn and we have to follow. So Director Sahab has very well said that the combination of integration of agricultural science with environment, what Dr. Ashok Juwarkar did was that time relevant. Still it is relevant and it will be relevant in future also. So if we say that multidisciplinary approach, if we integrate environment with any field, which is chemistry, biology, agriculture, medical science, so we can get better results in terms of betterment of environment. So thank you, sir, for your guidance, and I think NEERI will lay foundation on that, and NEERI will build up all these fields in the coming future. And whatever this Dr. Juwarkar has left, and he has guided us, so we'll build on that area, and actually the chief guest what he has told. So again, I am reiterating that we will use this traditional knowledge. Last but not the least, on participants, my colleagues, students, teachers, media persons here. So I'm really thankful to you all, because without your participation, this program would not have been possible. And because this is memorable one, because we are organizing Memorial Lecture. So we always try that such occasions we should learn something, and we should try to make such events memorable ones. So I'm thankful to you all for your participation, and from all my team members, and from indirect and direct participation, support, cooperation from my all divisions, R&D divisions, support divisions, director's office, garage, everyone, I'm thankful to them. So with this, I really I don't want to give to people, because this occasion is very memorable. And when I see all the sitting in the audience, I feel very privileged and honored. So I always think that such occasions should come again and again, and that is what this occasions are. So in the end now, I will just request you all to stand for our national anthem. Thank you.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा इंद्र हिमाचल यमुना गंगा उच्चल जलधि तरंगा शुभ नामे जागे तव शुभ आशीष मांगे प्यारे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे Jaya 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 He.
थैंक यू। आपसे अनुरोध करता हूँ बैठ जाइए प्लीज, किसी गेस्ट को पहले जाने दीजिएगा, क्योंकि वो थोड़ा सा रिस्पेक्ट है, इसका नाम आगे
तुषार तुषार
Very good.